What up, everybody? We are going to go through some recordings. We've been listening to um, the Celestial Theodolite stuff now for a while and just been getting clips of contradictions and things. We hear them say one show and then the next show they say a different thing, and it's kind of been going back and forth. So we're going to go through some of that here. Jason, can you hear me? Are you here?
Yeah, I'm here. Can you hear me?
Yeah.
Are you using Tahoe control?
No, I'm using a different thing, Pulse Audio, I think. Or
I'm just
no, I'm
getting right
using
into
that.
it.
Yeah, whatever you just said, that one,
Yeah.
the good one.
Is
All
that
right,
how you always overpower everyone? You're just like super loud all the time. You're like, fuck what you're saying. Here's what I'm saying. And you can
No,
do that with an app. Is that what you're saying?
I could do that, but I don't even do that with that.
I don't even do that with that. Oh, hold on.
Oh, maybe you do it inadvertently.
No, I just tune them out and talk over them, or just
Well,
turn them
yeah.
down on Discord and talk over them. Like,
Right.
I'm not gonna let someone just start talking over me. Like, that's insane. And talk over them, or just
Well,
turn them
yeah.
down on Discord and talk over them.
Or just turn them down on Discord and talk over them.
Video and then like
So that was something that I noticed from the beginning. Anytime that I would listen to them live, all the audios and everybody was fine. Like if I listened through EA or whatever through Discord, but then whenever I went to their YouTube page and tried to listen, and it wasn't even like just the Globers that would talk. It was like anybody real time that would ask a question, even somebody that's like friends with them would be turned way the hell down so you could barely hear them. And then you could hear him like starting to turn them up a little bit, like, and then, but it would be still not enough to really hear what they're saying, and then turn them back down again. And then if they had another question, you'd hear him trying to turn it back up again. I'm like, dude, that's a lot of work for yourself. You might as well use a freaking one of those apps if that's what you're trying to, you know what I mean? Like, if there's an app for that, why wouldn't you use that? That seems like a lot of work to manually turn somebody up and down. And when Jason was in there and I was trying to go back and listen to what you were saying, I heard him real time turning both of us down. Like we were at normal because we had never been in there and asked questions before, so we had normal, and then all of a sudden you hear both of our voices like drop down super low. And same with Electric was asking stuff, and his voice sounded normal, and then it went down really quick. I'm like, that's like what's his name? Alan Oakley. That's his new nickname. Um,
Yeah.
anyways, all right, I'll keep going through this.
other people watched that and went, "Oh, I'm so relieved that you looked into this now, and I don't have to look into it or consider it because you did, and you know the like." It was so sick to read the comments to be like, how much these like no one's gonna think for themselves. They literally went there, watched him talk about how he doesn't know a fucking thing about it, but doesn't like it, and how it must be wrong. Therefore, and people were like, "Dude, totally agree. Thank you."
I just had to put that in there because he's talking about, I forget who he was talking about, but this is exactly what his ether cult followers do. And you can hear in the rest of the video how they um, constantly, can't steel man it, can't can't they can only repeat word for word what Alan says, but or Shane says, but they don't actually really understand it, and they just like, oh, it's not my claim, I don't know, when they get put on the spot. And it's literally he's literally just described his own community of what's the word when they're all in a echo chamber. There we go. Sorry, it's still early. Anyways, I'll keep going through this. Unless, Jason, did you have anything you wanted to add so far?
No, nothing on that.
Okay.
I think you got it.
If there is anything, just start talking and I'll pause it for you.
That does seem to be the case with this celestial theodolite situation here.
And the fact that he actually said that does seem to be the case here. Like, not even realizing, like, whatever. I don't know. It just made me laugh. And we'll get into the stars below the horizon a little bit later.
Of the angle that it was occluded at, we can derive what the elevation would have had to have been, and we could derive what the distance would have had to have been, and we smoke them every time because they
At best, in your paradigm, is just a coincidence, and it just happens everywhere.
with the same factors, we're spot on for the distance, and we're way closer in the elevation angle. We got one for the globe where the distance between, and then so when we compare who was closest on that, let's see, the flat Earth was off by 172 meters. Globe Earth got 121 meters, so you guys were like a little closer. And then chord length might actually be closer on this one.
So chord length, that was the third thing that when he said that if we count for elevation, distance, and chord length. I don't know. What's chord length? Do you know?
A chord length is just like a straight line across two spots on like a sphere or a circle. So I guess what he's saying is like the distance from like the mountain to the observer. In order to get a straight shot, it would have to be a chord length. It would have to be a line through, through the globe.
Got it. Got it. Um, but yeah, so there's a lot of examples, it seems like. I thought it was funny that, this whole time I kept thinking that because they kept saying anytime we asked them or anybody else would ask them, they were just like, nope, globe's destroyed, RIP globe, you know, they didn't win, whatever. And so I thought that there was no, you know, like whatever it's called, measurements that actually lined up with the globe at all, but apparently there is actually quite a few. So I felt like that was kind of dishonest, like just be straight up like, dude, there are some, like it goes both ways. There's some that are null or where they're like about the same. And even the one that he did apparently, right, wasn't the one that he did like closer to globe
Yeah,
predictions.
right. I
That's
believe it's like the distance and the angle were closer to globe
yeah.
on one of
And the same thing with that goose guy did one and it was null, right? Like it was like right in the middle. Um
right.
so it's just dishonest to say that, like to act like, oh, it's a body bag, guys. This is it. Like it's not. Stop. Like I this didn't, turn me into more of a flat earther or turn me globe or anything like that, because it's just, it's numbers on a screen from another program of numbers on a screen. And so it's really not like some big aha, but apparently to these guys it is. So anyways, I'll keep going through them.
Because we got 57, so we're off by 7,000. Chord length might be closer on this one actually. But and we smoke them every time, because another one that you might want would be epsilon globe. That would be the refracted one. That would be the apparent position at observer locations, like the one that they always want to talk about but never do any distances off of.
Yeah, I guess we should include that one, even though it gives it the appearance of validity.
So like not much difference between us. We were both pretty close. And we smoke them every time, because
And it just happens everywhere.
light that we look through and measure things, like during the day, for example, and that gives us variations throughout the day that can't really tell us specifically what the elevation of something, like the true elevation of something is, but we can kind of get an approximation. What we have with the celestial theodolite is we're removing that variable of refraction, of trying to measure an elevation angle between us and a mountain peak, for example, right? What we're going to do is we're going to change things a little bit and use, we know that when it gets blocked, it's being blocked by a physical object there, right? So there's no refraction to account for or adjust or anything like that, right? It's blocked. So it is physically occluded by this object, right? So that's going to allow us to determine the elevation of the object that occluded it, like the physical elevation, where it actually is. And so when you,
I think at this point, this is probably the most lied about flat Earth piece of evidence I've ever encountered.
Because I assume that's going to be the next question. It's not on there, but I'm going to throw it in there for you.
Sorry if the audio like kind of fluctuates. Like I said, his audio is
Yeah,
super weird. So I tried
I
to
didn't know.
fix.
I kind of wanted to go in on what he just said there. I mean, the video may go into it later
Yeah,
about the occlusion. I mean,
yeah. Go into it.
is that later in the video, or do you?
Yeah. I have the whole sun clip and other clips of
Oh, okay, cool.
us talking about it in, like, I want to say a minute or two. It's like right after this part. Um, but we can talk about it now too if you want. Doesn't matter.
No, I just his wording right there. He said where the whatever blocks the light is in a physical location, and we know the exact elevation of that location because it blocks it, but then totally denies that when the sun goes below the horizon, then
Yeah.
it's not a physical location then that's blocking it. But it
Yeah.
has to be a physical object in an actual position to block the light.
Yeah.
But
And then anytime anybody
doesn't matter with the sun.
Yeah, yeah, just forget about the sun. And when people bring up the sun, like I'm not the only one. A couple people have brought up the sun. They like it's not analogous. It's not analogous, and they like jump on it like they can't. Instead of just answering it or thinking about it, they were just like, nope, nope. So, but then if you listen to what they're saying about the mountain, and they're like, oh, we know that that's its physical location, but then 2 seconds earlier he had just said, well, we don't know the real elevation. They didn't measure the actual elevation of the mountain. They're going off of stellarium. They're going off of like what whatever is listed as what the elevation is in Google or something. But it's not and as for their own, like the way that most flat earthers are like, oh, we don't trust what these people are telling us. We need to measure it ourselves, So why aren't they like measuring the mountain or using the measurements from um what's his face, Mike, to make sure that that's what I mean? Like, I don't know. It's like 1 second we don't know the elevation. The next second, well, we know the elevation. It's just like so many contradictions.
Right.
Which is it?
It contradicts their whole premise to say that they can use the occlusion timing to get the actual position, but whenever so that would mean that the horizon is an actual position when the sun goes behind it, but they say, well, that's not analogous to this method. We're not talking about that. Well, that's your premise for this argument. Then that premise doesn't account for other observations.
Yeah.
Like the horizon's different than a mountain peak.
Yeah.
Like I don't. It's retarded.
Yeah. Well, and even if you look at just the mountain peak and just what they claim about that, in one video they claim they don't know the true elevation of it, and then the next they claim to know its true elevation, and then even one of their minions is like, "We know down to the inch." And I'm like, "Shut the F up, dude. You don't know to the inch and nothing. Nobody measured anything
Nobody took a tape measure to a mountain. What are they measuring with? Like barometer readings, pressure readings, and even like the other methods of measuring it would be like theodolite measurements, which
Yeah, which they didn't use, and they admit that they
which
didn't
they didn't
use.
use, and they admit would are subject to refraction. It's an optical observation, basically.
Yeah,
So
exactly. Well, and like they moved the observer from where he was to the mountains, which doesn't make any sense to me. That we'll go into that later in the video too, but um, for like and then it's not like he recorded. He said that the very first, I guess, well, I'll just let it play, and once it gets to that point, I'll talk about it. Otherwise, we'll just talk about everything before we even get there. But yeah, I'll keep playing. And I like that they had this little graph. This was a more recent one to see a better visual of them side by each.
For funsies. So is it accurate for finding your distances? Let's take a Gandy.
Well, I'm not interested in the
No,
distance.
I don't
because
care what you're interested in, though.
I think your math for the distances
Nope.
is wrong.
One second, bud.
He's like, nope, just instant mute. And he even says, like, oh, I don't care, I'll mute people. I'm like, dude, like, I mean, I get that you don't like him and whatever, but like, you can't like beg people. It's just like William begging people to come in and talk to him, but then like when me or you want to go talk to him, it's like, oh no, except for you guys.
We can go over what the math is for the distances here in a minute. And I'm going to go over the distances now. So for distances, we have another here where the globe just barely slides in, I think, on that one. And then we are intersected there with them. So they're not much better than us in terms of our
But they're better.
60-meter accuracy there. And then we have Goose's measurement here, where we're all within the same range for who's more betterer and distinguishable there. And then when we do distances, because I assume that's going to be the next question, looks a little different there. But
Wait, what was that? I think I just saw something. Like, hold on. A clip of like a piece of paper? Hold on.
your accuracy there. And then we have Goose's measurement here, where we're all within the same range for who's more betterer and distinguishable there. And then when we do distances, because I assume that's going to be the next question.
Is this like what's I didn't even notice this till just now. So this is his script. We got a little copy of his script here.
What is it?
Oh my gosh, how did we miss this? I have this in the video and I totally missed this. When he moved over from page to page, here's a page of what looks like his script. Let me give you an example of some
Is that
answers.
is that like quit? I know that they like wrote down
Oh, no,
questions
no. Okay,
people
that's
had.
by Jesse G. Okay. Answered. Okay, the following question should be asked and answered by Jesse G. 8825. Still, I just thought that I just caught that right now. I'm like, wait, what was that? Does it even work to measure the known delta height of a mountain? This is great. Sorry. Anyways, all right, we can keep going.
Makes it looks a little different.
Because didn't that happen before, where his like script got like shown on screen and people were like, "Huh," or like he was using, what's it called? That
Chat
AI?
GPT or something.
Yeah, ChatGPT, whatever.
There, but
Funny.
you guys get that one there. And then we have the other blend. We are just off on that one for distance. But again, our LEs were mismatched. And then we have distances for this all good here. Now, when you say that you disagree with how we're doing the distance, I'm doing the mountain elevation, the one known thing, and then the occlusion angle, which
The one known thing that we didn't actually measure, that we don't actually know, and admit that we don't actually know.
is our dependent variable, which depends on when the star gets occluded.
That distance I'm okay with. If using that method, if Earth were flat, that would be the way to get the distance. But I don't agree with how you're doing that for the globe.
Okay. I have several and to be clear real quick, I have no problem muting people or censoring.
Oh, look, it came back to this page again somehow. So is Jesse G, is that the Jesse that we're talking to? Because, like, that kind of proves that they're same team in a way, even though they, like, play fight with each other. Because I'm convinced that a lot of these Globers and Flat Earthers, the way that they argue a lot of the time is, like, very suspect. Like, they know the questions that are going to be asked ahead of time. They talk about it ahead of time. They have their certain topics that you can hear them avoiding or kind of skipping over that shouldn't. Definitely, if you're like a real glober, a real flat earther, you wouldn't be just skipping over shit. Like they just want to keep the conversation going because that's how they're getting their paychecks, you know? But that's just my own little side conspiracy.
Them over retarded shit like this. I don't care. Anyway,
So
continue.
To go back on what he originally asked, like about.
So I don't remember this being up on screen this long. I don't know how this got paused up here while I'm talking, but that's pretty funny also. Anyways, I'll keep going.
The globe having some instances where it was closer or it was null, like it could go either way. How many would you say lean more towards globe versus flat? And then, like, I guess how many were right in the middle? Have you like tracked exactly like a number?
Yeah, so I should get the number out, but it's we can look at it real quick. It was the mismatches are, let's see, Blodgett and Houndstooth. But we already knew that. Getaway was one. So our elevations are similar. And then
But I guess I just was trying to figure out exactly the numbers because I thought that there were none, like from all of the stuff that I've listened to from you guys. It's like you guys kept saying that there's none that the globe matched up with. And then I'm hearing that there actually are some that the globe matches or that are evened out. So that confuses me, you know?
No, it's a great point. So if you go by no air margin and just who's closest and like no like parameter set, then we're closer every time except for in the instance of Blend Mountain, where the true positions are basically the same as the refracted position.
And Blodgett Peak.
Maybe you should tell her why that is, though.
Yeah, well, like I was saying earlier, when we look at the
And Varley was a globe match.
oh, blend.
I love how Jesse just keeps jumping in, like, and this one, and that one, and like Alan was just trying to claim just the one, and like, I'm just glad that we got them admitting it finally, because in nowhere else, it's always every other video, it's like, nope, we destroyed him, and then all their minions go around repeating it word for word, and I'm like, wait, but it's not every single one of them. We can hear it from his own mouth. And I think he says that the ones that are like further distances, which would make sense because like refraction is gonna get
So that's
there's-
three.
we ha-
So
oops, sorry. Refraction's gonna get worse the further or like more, you're gonna have more refractive index or whatever for further distances. So obviously it's gonna, I don't know. I mean, I guess that kind of makes sense that the ones that are longer are like that. Are you still with me?
Yeah.
Okay.
Yeah, no, I agree.
Wait.
right, or how many do you know, Jesse? How many total went
I
more
think-
towards?
The fact that he just doesn't have a number either, that he can just rattle, like it shouldn't be that hard. I'm asking for two numbers. The numbers of the ones that were the globe one and numbers of the one where they're like equal or whatever. And he's like, yeah, I have them somewhere here. Or I should get those.
Because I'm just trying to get numbers here. Like, okay,
when you say more towards, it would be like if they're both better than the other prediction, that would count as like a decisive one. So none of those exist for the globe where it's decisive. We
were
have
all of them? Okay.
we have mismatch measurements where it's off.
You're saying within the margin of error, right?
Right.
So,
Right.
like, if neither are within the margin of error, then it's kind of essentially, I guess, you throw the measurement out, and you have flat.
It's not a different.
So also, so there is a margin of error. So flat Earth was never on 100%, which is another point that I feel like they keep saying flat Earth was on 100%, and it wasn't. Like they still, like it still wasn't perfect either, Like they were
Right.
like every single time you hear them talk about it, they're like flat Earth was off by this much, globe was off by this much. So I mean, even that, like if they're for their own argument, like shouldn't they be 100% on then? Like somebody brought a Glober, I think, brought that up at some point, but I thought it was a good point. I'm like, yeah, I guess why, if it's just a flat, like they're not actually taking real measurements out there. It's just based on stellarium and whatever. Like, shouldn't flat Earth be 100% on, or like like way closer? Because there's sometimes like both are way off, and like that's confusing to me. Like I don't know.
Right. If it's within the margin of error, then it should be spot on within the margin of error. If it's flat, if they're if they're eliminating any kind of refraction that they claim to do, which then it should match perfectly to flat within a margin of error. But if it's out of that margin of error and they're claiming flat, it should be spot on.
Yeah, exactly.
Different position than like altitude wise than whatever the apparent position would be. Like there are the same position. Like it's not. Right. I don't mean like I know the elevation or anything like that. A 4 arcsecond difference between their apparent position and the true position intersecting it.
So in that part, I know it's kind of I clipped a lot of the stuff together. He was talking about the elevation of the star, but wouldn't they have to claim the true position or and claim elevation of the star to get their measurements that they have, or am I looking at that wrong?
Yeah, which they claim the true angle position of the star is based off of the that 15 degrees per hour from the where the point of Aries was, where they take the measurements vertical to the star and then add 15 degrees per hour, and so they're saying that's the true position or elevation angles.
Oh, got it.
Is that
So
what you're saying?
it's the angle. So it's not because there's certain points where he's like, we don't claim to know the true elevation of the star, but then in other parts he's saying, well, we know the elevation of the star. So I'm like, wait, but I thought you just said you don't know the elevation of the star.
Right. They're saying they know the elevation angle based off of the model of
So
the
they just
15 degrees per hour, but they don't know. I mean, I think they rec. I think they're using the language wrong. He should have said angle, but
yeah,
elevation. I mean,
yeah.
nobody knows the elevation, the actual
That's
height of the stars.
I think that's where I was getting confused too and kept hearing contradictions because I'm like, wait a second. One second you say you don't know the elevation, and then the next you're saying, well, we know the true elevation. And I'm like, maybe if he said elevation angle, then it would have clicked with me a little bit more, but he doesn't use the words, I guess,
Right.
properly. I don't know.
At that elevation, position intersecting it at that elevation.
Yeah, work out one of the examples yourself. Like, go look up an elevation. Like, understand the
take an
process.
optical.
And once again, go look up the elevation. Or maybe he's talking about mountains there, but still, like they're looking up elevations of mountains. There's no real measurements. And even when Dr. Mike said he took a real measurement, he said it was spot on with flat Earth. It was perfectly matched flat Earth, was his words. And so, but then they're just going to discard that, and he's not going to show, a screenshot or a picture of him doing any of these measurements. And then, oh, we're just not using those. Like, if it's spot on, then why aren't you using that shit? Like, here, they even have a little, here's little Dr. Mike, here's his little camera and his little timer. You know what I mean? Or his little, I mean, I guess, I don't know, he's using a camera here because they took
Yeah,
the
that's just for
theodolite
the
away.
timing. But right, that's just for the timing, which is what they used in the method. But he did take a transit measurement, which is like a theodolite. It's not really exactly a theodolite, but he took an old school transit and it does take angle measurements. And he took that and he said it matched spot on to flat Earth. But then he rented or borrowed another theodolite, and it did not match flat Earth.
Yeah.
So
And
he
neither
had some
one,
speculation of why um, that he didn't really state, but we knew what he was saying. He
yeah.
thought it was like fudge factored into the device to make it look like a globe, but uh, that can't be the case. You don't the device doesn't know like distances to what you're shooting at or whatever to know how much to curve to apply
Account
to it.
for. Yeah, kind of like the claim that GM tries to make about accelerometers being, having the gravity is programmed into the accelerometer or whatever the fuck. That's kind of what it reminds me of. But he never showed any like evidence of either one of those measurements, right? Like no pictures or video or anything like even, and then
Not that I know of.
and then they never went into any more detail on it, right? Like they just kind of like from what I've gathered, he talked about it in the beginning, but then they never used any of those measurements. They never, there was never any proof of any of it. They just basically ignore that and just, everything that they're doing is just basically all stellarium based, right?
Right. Which I mean, I understand from the point of the method they're trying to use, um, but the method has many other flaws than that. Which I won't like dog on them too much for using that for the method, but it is bullshit for a flat earther perspective of not taking actual measurements and just basing it off of some model, like some globe model, using a globe model to try to prove your flat earth. Yeah, that's some bullshit. But as far as like intrinsically to their method, I understand that's what they're doing. But yeah, I get what you're saying.
Word.
Cool measurement. We take a timing measurement based off when we can't see the star, the globe, but we can derive our distance and we can derive the elevation of the mountain peak.
Of the peak because we know the exact elevation of the mountain peak. And it's very tippy top. So when you're looking at, oh, the mountain peak is at this elevation, that is actually the tippy top. And it's really accurate, I'm sure, within, feet or inches, maybe even. So you're using that to establish that angle to the mountain peak physically. And then you already know the elevation of that mountain peak. So that gives you two angles. That gives you two sides of a triangle.
Later towards the end, I'm gonna share the clip of his triangle debacle with Tune, and it's it's really funny. But yeah,
It's just optical.
It's just optical. I have that clip in here a couple times. It's just optical. Like they want to claim it's just optical, but then only when it suits them is it optical. Or you know what I mean? Because then like
Right.
everything in flat Earth is optical. Like what he's saying. So yeah.
True position. I don't mean like I know the elevation or anything like that.
Celestial,
I just
does the
mean
celestial theodolite broken? Does it give varying results? No, when you properly I'd have the peak identified, you're good to go. Why it's off and doesn't look right, I have no idea. But the numbers speak for themselves. That's all I can say about that.
That's all I have to say about that.
And we smoke them every time. Time anyone's ever used the quote unquote true position of a star for anything is no one's ever used it for anything except for us. And when we do it, we can show that the Earth is measuring flat with respect to the stars.
Somewhat flat with respect to the stars because it's not perfectly on and how do you know that you're the only person that's ever like I'm pretty sure there's like astronomers out there that have used true positions for things and stuff that they're doing, right? Like that's a pretty bold claim to say that, like, I don't know, I'm just saying. um and then you had to I love your name, Unifarts. Um like so I don't know if any of you remember, but couple months ago Jason got booted from their server for privately messaging Alan some questions that were going back and forth about upward stuff, and Jason was totally respectful and everything and just asked if what was it? You asked if what is or how do they measure force, and he like got triggered at that question for some reason and blocked him and booted him from a server for asking how to measure force. So he started a sock account, or oops, I shouldn't probably. Fuck, should I take that out? Just
I
expose.
was wondering.
But cool. During recent stream, I keep hearing Alan say it. They were closer to a globe. The other two responded in like a very word salady way that wasn't really like, at least Kat kind of here we'll just read it. There are a few cases where the globe angle is closer, but in those cases the flat Earth angle is close to the globe angle as well. So when globe and flat are close to the same, globe has one. But when we look at the ones where the difference between the globe and flat is greater and a more distinguishable, flat is always closer. I'm like, flat is always closer, except for when the globe has one. So, yeah, I don't know. That just makes me laugh. Yeah, this is Alan's response. I'm not even gonna read all of it, but it's really um long. Like I didn't even post the whole response because it's like and same thing with Geo or anybody else. I ask like a simple yes or no question and the answer is like 3 paragraphs not answering the yes or no question that I just asked. It's ridiculous.
Rule of refraction. I'm pretty sure doesn't even take into account curvature for their refraction. Doesn't even take into account curvature for their refraction.
So had to put that in there too. We're not just trying to sit here and clown on the flat earthers only. Like, obviously we're still flat earthers, and we're pointing out inconsistencies and things, but there are also similar inconsistencies within stuff that the Globers say as well. So anyways, good catch on that, Jason. That was from you.
It assumes a flat atmosphere.
What's up?
No, nothing. I was just that what was he's saying basically that like the refraction or really the stellarium doesn't even account for globe curvature, just refraction.
Yeah.
Like
So
the curve is in refraction is in the refraction.
So how can they even claim that stellarium is a globe model if that, right? I mean, wouldn't that mean that it's like they use a flat bit? Because I thought this was a discussion people were having 10 years ago about how like stellarium is based on like a flat, and they add in refraction and that's whatever. But like, but as far as the actual, you know, measurements or whatever that they I don't know, I could be wrong about that, but I thought that was something that was like debated years ago, and that like the Globers even admitted that like, oh well, yeah, we use this for measurements, but not for like real life or something, or I don't remember what the argument was, but anyways, I just think that's interesting that he's like, I don't even think they have curvature built in, like, I don't know. If anybody else remembers that from back in the day, let me know if I'm misremembering, if I'm Mandela affecting myself here or what. But anyways, I'll keep going.
I think.
So my question is refraction actually completely eliminated from the equation, or is there still a little refraction being accounted for in the flat Earth computations? I just don't quite understand that.
No refraction in flat Earth. We do account for it in the globe, though, perfectly with Gigi Bennett.
So the stuff in the sky is like unique to us. So like I don't think like there's a need. There's not a need to like even give a physical explanation to it because like I don't think I haven't seen the Fresnel video, but I don't think it's because like I already said, we're not saying that refraction doesn't exist, and you started off.
That last clip was a response. Like I haven't even seen the, whatever Pharrell video, so he was referencing the Skiba video. So I think like a month ago, Jake had brought up the Skiba video and he said, "Oh, I'll watch that. Oh, I'll watch that." And just even more proof that like Alan doesn't click the links and doesn't watch the videos he says he's gonna watch, because then a month later when I asked him, he was like, "Yeah, I haven't seen that." And I'm just like, dude, how can you be the one running Globebusters and you haven't seen like one of the most popular among flat earthers, the most popular like sun setting video that's probably ever existed, and you haven't seen it? Like, and then even when people tell you about it and you're like, yeah, I'll watch it, a month later, you still haven't seen it. Like, that's embarrassing, bro. Oops.
Off with, you guys are denying refraction to the magnitude in which you guys apply it for daily observations to confirm the elevation angle of the mountain that comporting with globularity that isn't.
All right. First of all, you said you don't deny refraction. Where is refraction in the prediction?
Negligible. It's neglected. It's a negligible term.
So is the flat Earth prediction wrong?
No, man.
No, it's negligible because refracted images don't block physical objects.
Well, again, I'll just show you my slide to show you.
There's that again. Refracted images don't block physical objects.
What's actually happening?
Okay,
Hey,
we're asking you to steel man our position. So
yeah, can you
Put
steel
the
man our
observer where
position?
he's not. Is that correct?
No, man.
Well, how about
you have a good day, Riff. It's been real.
Wait, hold on. What is this argument about refracted objects don't obstruct, what, physical things, whatever? What's that? What's that argument? Because last I checked, all right, if you refract something, right, and that thing goes up, right, there's clearly something like behind it, whether it be sky or a wall or whatever, right? It's going to be obstructing whatever that is right behind it, right? Like, I don't get this. This is a weird argument. Like, you really mean to tell me you don't think refraction can bring up the mountain, but let's say also like bring up the, the star or vice versa? Like, I don't get that argument. Like, it's not. Like, you could just do it.
Your incredulity doesn't detract from the point. So
Here. So if an actual object has to be occluding light, then how do sunsets on a flat Earth?
Ooh,
Because
great
the horizon isn't blocking. Like, you've seen that Skiba video by now, right? I know somebody brought this up to you like weeks ago, right? Jake, I think, brought it up.
So I haven't seen the Skiba video. There's the one video that I'm aware of where he has the sun on a mirror thing and he's moving it away and it looks the same or whatever. But yeah, so the answer to that.
Wait, so maybe he did see it then. Is that the same video?
No, but there's two different ones. There's one that the Skiba does that he shows the size difference or the size of the sun staying the same with the magnifying glass or the Pharrell lens or Fresnel lens. But then there's also the one that I put in my video where it makes it actually set on a flat surface. It makes it go under the flat surface with the lens.
Yeah, got
and
it.
that's what he's trying. He's seen it, and he's acting like he hasn't because it completely destroys their argument.
Dude, sneaky little fucks. Yeah, I forgot about that other Skiba video. It's been a while, but yeah, that makes more sense that I haven't seen it. That's always the claim, right? When they don't want to talk about something. Like the whole time I was debating, I put debate in air quotes, freaking Witsit. Anytime he didn't want to answer something, I don't know what you're talking about. I didn't see that. I'm like, it was literally in my presentation. You were just here watching. What do you mean you didn't see it? Like, but that's always the
just
claim.
like Alan. Just like Alan in our comments back and forth. when all I wanted him to do was just watch a 4-minute video, and he like it completely destroying his argument, explaining, the upward deal with, the dynamic equivalence and kinematic equivalence, and he wouldn't watch the 4-minute video.
Yeah.
And you even going back and forth with him, and he said, "I won't
I'll watch
respond to you again until I watch the video." Well,
And
he
then
was right. He didn't respond.
he never responded. Yeah, exactly. And I just kept saying like over and over, just watch the video. And then he would like respond with this like 3-paragraph long thing that clearly took him more than 4 minutes to type. And I'm like, bro, if you would have just watched the 4-minute video, you wouldn't have typed this whole fucking thing. And I'm like, I know you haven't watched it, because he tried to lie and say that he did watch it. And I was like, okay, well then why are we still talking about this? And then he's like,
Right, because
okay.
he
Sorry, go
kept just like repeating his script, like the back and forth. We were explaining exactly what we were saying, but he just would just copy and paste a script, like saying, "No, it's just kinematics, just kinematics." No, it's not. I'm accounting for the same variables that Dr. Bennett did in his analysis, and he's like, "Nope, that's just kinematics." And I'm like, "Dude, just watch the fucking video."
Right? It's so painful. Like, bro, you just wasted an hour of time going back and forth with me about it like you don't want to watch a 4-minute video because it's too long, but you'll waste an hour like with this bullshit. It's ridiculous. Or he probably watched it and was just like, I don't know, I
Right,
don't want to watch
exactly.
it. Yeah, exactly.
Just like the Skiba deal. If he's seen it, 100% he's seen it. He's just,
Bullshitting.
he can't own up to that because it destroys him.
Exactly.
That is just limit of vision. So at a certain point, it just gets too far for you to see. Same with the stars. Otherwise, how do the stars set?
So because there's times that I've heard you guys say that the horizon is apparent. So in that case, would an apparent object be blocking a light source?
No, because it's moving away, and there's atmosphere between you, so it's limit of vision, and through the atmospheric what do you call that? The obstruction.
Opacity.
It's the atmosphere.
Okay, so the
See,
atmosphere
that's
can
just
be
dishonest,
counted
man.
when it comes.
Sorry. Yeah.
That's so dishonest. I hate when flat earthers do that, because 99.99% of the time we watch the sun like over the ocean. When you watch it set, you see the sun be blocked by the ocean.
Yeah.
I've seen the ones where you can see it goes away and it gets blocked by the atmosphere, but it's such a small percentage to say like their whole premise being that an apparent object won't block the light source, and then act like the sun doesn't do that.
Well, and then claim too that it's different. They're talking about lights in the sky, but the star and the sun, the two celestials that we're talking about, they're not comparable. They're not something that they're like, no, it's a different thing. I'm like, it's not a different. It's the same. What do you mean? Like, I mean, I get that the sun isn't a star and whatever, but they're both celestial lights in the sky that like but I think I bring that up right here, and they just, you'll hear their response.
To sunsets, just not occlusions of stars.
When you don't see them because it's far enough away and there's nothing blocking you, that's a different scenario. In this
Yeah,
scenario, there's
exactly.
something between you and the star, so it's not exactly analogous. Because if there's nothing
Not at
between you
all.
and the star, they just set in due to the limit of your vision, same as the sun.
Also, if you live in a valley, you'll have different sunrise times, and they'll be based off what you're talking about. So
the
you know.
Yeah, like
horizon
just
still
before
apparent.
it's blocked.
Oh,
Just
are
before
they
it's
based off
occluded,
of the
you can
physical
see.
occlusions too, Torah, for the valleys?
Yeah, like if you're in a valley
Oh,
or something. Yeah.
oh, that's so interesting. But the truth is, it's always apparent.
So yeah, it's so interesting. Like I don't know. I'll just keep playing. It's ridiculous.
There's no physical body. This is only an idealized snapshot or reference, right? It has no relation to the measurement of the ground. This is just for precision and accuracy. Because apparentness, because some people will say, how does the sun set? Because they think it's like a physical object that's set behind a body, and then like an apparent image is like refracted up a little bit. But the truth is that it's always apparent, and we have documentation from a solar panel manual from the 60s describing how
corrections. And don't get me wrong, I think it's fine to use terrestrial refraction because it only makes a difference of like 2 arc minutes anyway. and obviously it's happening between us and the mountain. Like that's a fact, right? It's always going on everywhere.
That it completely
Hold on.
undermines all the.
What's it?
Yeah, just take a snapshot right there. What is the timing? Where's the sun at? That'll tell you how high the horizon is, and the distance, and the angle. Take a snapshot, see what the timing is right there. No, it's just going away because an apparent position won't block a light. Oh, it won't? What's the sun doing right there? Oh wait, what about the boat that goes across? Then that's above the horizon. That means it's in an actual position, and the sun's going behind it. Does that mean that the sun isn't being included? What? Dude, it's retarded. I don't see how they don't see the flaw in this.
Right. It's like they're paid not to see it and have blinders on or something. It doesn't make any sense. And they're the new leaders of Globebusters. Like, wow, dude, this is how far we've fallen.
Right. I get. I'm a flat earther. I know the sun's just going away, but they're using the argument that there's no refraction. There's no refraction. It's negligible, but the sun is going below their feet. Like the only way the sun can go below your feet is if the light is bending. Like if it's not going below your feet and you're seeing it blocked, the light is bending, and nobody will know. Flat earthers are going to hate on me, but the only way that can happen is if light is bending. It's not just perspective. Perspective is straight lines. You have to claim refraction.
Yeah.
Which I'm okay doing.
Yeah. And I asked him, I don't think I have it recorded here, but in the same conversation, I think before, the first thing I asked him was, so do you believe that light bends? And he's like, yeah, duh, of course. Like, we have examples of that. Like, I'm like, okay. Just asking, because I don't know. Like, like, you would, for the claims that they're making, you would have to be saying that light doesn't bend. And, like, I don't know if we should get into your upward
No,
theory.
we're not yet.
Okay, all right.
Not yet.
Okay.
AV where like it just takes refraction off the table, like just altogether, and then they're left with we've established that the measurements alone can't tell us anything because optically it could be an optical phenomenon, or it could be a physical earth curvature phenomenon, or it could be a combination of the two where you have refraction. You introduce refraction into the earth curvature to make it, which turns the measurements into the planar equivalent. Could be any one of these things. So only when the physical object is intersected by the light source is when you actually get the occlusion. So only when the physical object is intersected by the light source is when you actually get the occlusion.
Even if you have a bendy light, you still need something to block it.
Physically, right? That's the point.
Physically, yeah.
So that when the star goes behind the mountain, it's actually going behind the mountain. It's actually physically being obstructed, no matter what refraction you have before or after. It doesn't matter.
This is what the camera view of Goose's video that he was showing earlier looks like. So when he was showing the topographical view of what we were looking at there, where he was laying out the positions of everything in the alignments, this is what we're looking at. So if you could, so this is in air, then this is the top view. So we see the string stick that he's moving, the light source with, and then now he's added a medium over top of it. And this is what it looks like from the camera angle. As you see, the image sticks around a little bit longer, and it's not occluded until the physical intersection point happens in reality. It's not occluded until the physical intersection point happens in reality. And then when he gets to the topographical view again, you can see the angle difference of the true position of the light source, showing that it doesn't matter if there is refraction or not, because the occlusion is physical. What we've uncovered is that occlusion is a physical intersection. It's not apparent, like an apparent mountain or an apparent object will never occlude a light source. An apparent object will never occlude a light source.
Now imagine yourself so small on this paper, and you are trying to triangulate the bulb, but you have no idea if there is any lens in the sky, because you just can't see it, like you can't see the atmosphere. So your triangulations will always fail, because they will always give you a different distance to the bulb, because the bulb is not what you think it is. You are just triangulating a reflection of it with that. But even if the distances were 100% accurate, the triangulations would never work. And I'm going to prove what I'm saying with another experiment. As we said in the previous videos about refraction, the sun is never in its real position. Even modern science agrees with us. What you are triangulating is a reflection of the sun, and this is why your triangulation would never work.
Buddy, no, it's because they're in a
So I clipped that. That was like an old video, right? From like a couple years ago or something, 4 years
Probably
ago.
5 or 6 years ago, probably.
Yeah, right. Um, so I mean, yeah, you can watch that whole video on his channel. I forget the dude's name even. Was it Dr. Zach or something?
Yeah.
So, and he shows his demonstration and whatever. It was really long, so I didn't want to if somebody wants to go check it out, they can. But I feel like most people that have been here for a while has seen that by now. Apparently, maybe Alan has not. I don't know, or Alan and Shane or whatever. But did you want to add anything to that before we move on to this goes into the parent position thing?
Yeah, it's just another example of like everything having to be refracted. You only see everything in their apparent position, which they definitely admit that, but then act like they don't have to take into account refraction in their observations
What?
to match the prediction of a flat Earth or whatever.
Yeah, exactly.
parent
position. Why are they in it? Why should I believe you with your religious claim that they're in a parent position instead of an actual position?
What's religious? What is the actual height?
Yeah, what is the actual height?
What's the difference between the two?
What is the actual height? That's a great question.
Talking about points.
Above flat Earth, what is the
because it's taking in the distance between you and the star, right? And it's
an old David White.
So, obvious, and this was after that conversation was weeks after the whole apparent versus actual geometric debate. So I guess he wasn't around for that because he's like, no, it's an apparent. But that's and he's on the flat Earth side, whoever that guy was. I don't even remember what his name was. But he's fighting for Alan and Shane, but doesn't even know that Alan and Shane call it an actual position, not an apparent position. So once again, their followers aren't even following what they're saying exactly, But yeah, anyways.
8300 and measured Pike's Peak with it. And the very first measurement on that old theodolite came up to exactly what the flat Earth would predict. And that was from my house.
So it matches with flat Earth perfectly, but you're not going to show evidence of it. There's no pictures, there's no video, and you're just going to ignore this whole thing now from here on out. It's crazy.
And that's when I began to realize the big problem is refraction. And what I was hearing in the debates is refraction numbers are all over the place.
Oh, and I had to leave this in because when I looked this Seattle Theodolite up and this advertisement for Idiocracy comes up, I'm like, wow, that's funny and random and and it's an old ass movie, so
that old theodolite was more than adequate to detect that difference. But I realized that because refraction is the big issue, it doesn't matter what theodolite you're using, refraction is always going to be the issue. And
this is not the ideal spot to be like, oh, dude, this is like if I were a glober, right? I wouldn't hinge my flat Earth refutation on a measurement that where it's like,
hey, I'm sorry.
So it could go both ways though. If you're a flat earther, I wouldn't hinge your flat earth reputation on what these guys are saying either. So anyways.
I missed the night, but I would like to say a few words too at some point.
Naturally.
That's the point. Go ahead.
Is it that point? Yeah. So yep. I just, I'm sorry I missed Alan. I composed the thing. I know Jesse's seen it, that I posted in the chat there. And it was interesting because in talking to Alan on another server, he claimed to agree with me 100%. Because it's just a tautology that you can only see things in their apparent positions. That's what it means to be the apparent position. And a corollary of that is that any method
That's an
that
excuse.
predicts an occlusion time that occurs at anything other than a time when the apparent position of the star is the same as the apparent position of the peak is simply wrong by definition. I mean, that's when it happens by definition. And Alan claimed to agree with me. He claimed that he couldn't agree more with that, which I thought was interesting because, of course, the globe CT method simply asks that question. So if you want to predict when an occlusion will happen, you simply ask, when is the apparent position of an occluded star the same as that of the peak that's occluding it? That's an easy question to answer. For instance, for an observer at Mike Heffron's house, 39 Aquarii is occluded by Pikes Peak every day. And if you want to know when that occlusion happens on any given day, like today, all you need to do is give Stellarium the coordinates of his house, choose the day of interest today if you want, and find the time when 39 Aquarii appears 2 degrees and 19 minutes above the western horizon, because that's the apparent height of Pikes Peak. And if the visual elevation were 2 degrees and 33 minutes, as it would be on a flat Earth, that daily occlusion would occur about 80 seconds earlier. And that's about all I really wanted to say.
Wait, 80 seconds
Okay,
earlier than what Alan and them have been saying that it.
Yeah.
Oh.
The time that he said that he saw it, it was at 2 degrees and 19 arc minutes above western horizon. That's exactly what you'd expect because the Earth is a globe. If the height of Pikes Peak, if the visual elevation of Pikes Peak were 2 degrees and 33 arc minutes, as it is on a flat Earth, that occlusion would have occurred almost a minute and a half earlier.
Wow, that's really interesting. I've actually listened to you before and I saw what you were talking about, that conversation between you and Alan, and he did say I couldn't agree more, blah blah blah. Like I
Yeah.
saw that. And then also I've heard you talk about like the accelerometers reading upward motion. How does that work on a globe? Like, how would
Oh,
an upward movement, like, wouldn't the globe be expanding? I know this is a different topic, but I was
yeah,
curious
I was
and
going to say it's a different topic. I'm happy to
sorry.
talk about it, but let's see what the room wants to do.
Yeah.
Yeah, I would like
Yeah,
to wait a
that's
little
gonna get
bit
into
before looking into that.
Einstein and it's
No,
yeah.
it was a really quick question. Like, I didn't think that, we can not talk about it right now. That's fine. But I've heard him talk about, like, agreeing that there is a motion upward that's been measured. So, yeah, but we'll go back to the other shit. That's fine.
Well, I don't know. It's kind of rare that you
I
guys
just want to
are.
hold. Sorry.
Well, if we wanted, it is if you guys don't always have if it's somewhat rare that you're both in here. I mean, John, if you wanted to give like a minute, a response, and then we could shift.
I can leave it under a minute. Yeah. What I meant by that is there is a thing called absolute acceleration. Unlike velocity, there's no instrument that will tell you how fast you're moving without referring to something else, because there is no such thing as absolute velocity. But that's not the case for acceleration. You have an accelerometer in your phone. It tells you how fast you're accelerating if you're holding the phone in your hand. That's an absolute measurement. And when you're standing on the surface of the Earth, your absolute acceleration is 9.8 meters per second squared upward. And we can go into it. Doesn't mean that the Earth is expanding. It's a little hard to understand why that's the case. That's what would take a little longer. That's the 1 minute spiel.
Yeah, that's the part that I was wondering though.
Yeah,
like, for
another
me,
time maybe. I love to talk about it.
Yeah, no, I definitely I'll send you a friend request and maybe we can go in a separate room or something so we don't bog. I know nobody in here wants to hear about upward and whatever, but I only see that happening on a flat Earth. Like I can't see the upward motion happening on a globe or concave, because the concave would enclose on itself and the globe would just be continually moving out away from itself, which doesn't make sense in my mind. So yeah,
No, it
anyways.
doesn't. And I get that. I get why it seems like that's the case. Yep.
I would just.
At least he says he gets why, it seems like that's the case. Like, he can...
It seems that that's the case because that's what's measured, and you just admitted that. You said absolute acceleration can be measured. And what is the accelerometer do on the ground? It says you're accelerating up at 9.8 meters per second squared. Like, dude, that's so good that you got him saying that.
Like what kind of crazy magic tricks does that work on a globe? Like it
Right?
just like it makes no fucking sense. And what's even more telling, it shows me that I mean, throughout all of the conversations that we hear in Geo with the TFE, with anything, he's taken the Glober's side. Like he's a legit like closet Glober, you know? And he's like, oh no, we're not gonna talk about that. Oh no, this isn't, whatever. And then, when Jesse was having his conversation with him about TFE, he just kept white knighting for Tune and then saying, we need to change the topic. And like, even though it's like the whole room was like on fire with questions and he's like trying to shut it down. I'm like, geez, Gio, you couldn't be a more obvious freaking gatekeeper right now, bro. Like, what is
Right.
wrong with you? Um, but yeah, anyways, did you want to add anything else? Because this goes in back into the other stuff where it's not back into like upward, but I figured like this was a good time if you wanted to, or if we wanted to do a separate video about light and like what your thoughts are on the possibility of what we're observing being tied with the acceleration upward.
We can make another video on that.
Okay, all right, weird.
Say there's
Sorry.
no motion at all because the accelerometer
change. He wants the stellarium from Heffron's house now.
I already have that in my analysis. That's the entire backbone of my spreadsheet before I even adjusted to the terrestrial refraction thing that they also want. I've got comparisons for all that. That's already in my thing. And even
So he did add terrestrial refraction. So that's another thing is it's like some of this was recorded beforehand and I get that, but there was stuff more recently, even just from this last week, where they say they don't account for refraction and that refraction is null and all this stuff like that. So but then I've heard them
Wait, did
say
that
that
just was he saying on the flat Earth prediction he just added terrestrial
terrestrial,
refraction?
yes, yeah.
Oh, yeah, because I know that they admit that they like for the globe predictions they add in terrestrial and celestial refraction, but for why now he's saying that they did do refraction for the flat Earth measurement.
Yeah. That's
Hmm.
that's one of the contradictions I was confused about because they basically after arguing what it sounds like happened is after arguing with the Globers, they finally like caved and and added terrestrial refraction in with something, or I don't know. I mean, we can re-listen to that. Maybe I'm misunderstanding that, but he said that the backbone of his whole thing was Mike's first measurement, but then they never talk about it again. Like they don't use it in any of their measurements or any of their stuff, so that doesn't really make sense. But then, like, hold on, let me just rewind it a couple seconds here.
Heffron's house now.
I already have that in my analysis. That's the entire backbone of my spreadsheet before I even adjusted to the terrestrial refraction thing that they also want. I've got comparisons for all that.
That they also want. So I think
Yeah,
he added in, yeah. So I don't know. Either way, 1 second, no, there's no refraction. The next second, maybe they added in terrestrial refraction. I'm not sure. It's very confusing.
Yeah,
That's already in my thing.
just go back and forth.
What's that?
I said it's so confusing. They just go back and forth with everything.
Yeah, they make it like so over like, and then they're not even like straightforward about it. Like and then like there's clips of people of all the little minions coming in and saying, "Oh, it's so simple and so basic." And it's like, "No, dude, these own people that are doing these conversations don't even think it's simple." Like there's a point in here, I'll stop talking and just play it, but basically he says that he admits that he didn't even understand. He was arguing that Jesse's way of doing things was wrong for like months, and then he did a video like a week or two ago, week and a half ago, like admitting that he didn't fully understand any of it, and that he finally got it because Shane showed him some of his slides or something, and then when he wanted Shane to share the slides, Shane was like, "Oh no, you got it, you got it." But the rest of us don't got it. Like if it took the guy who's presenting this weeks or months to understand, like, and somebody had to walk him through it, then like the rest of us are clearly not on the same page because you know what I mean? They're not even explaining it properly. So, anyways, I know I'm rambling on, so we're just gonna keep playing it and you'll hear for yourself.
And even
Well,
in
what I
go ahead.
what I don't understand, and I mean, I know that's what they want, but we're using a mountain to occlude a star, and it's the
Yep.
mountain that's occluding it. It's not anything near us at Heffron's house. It's at the mountain. That's what's occluding the star. So they're wanting to bring it back 50.7 kilometers. They're not only bringing it back 50 kilometers, they're also changing the elevation of the observation. Because, you know, the mountain's higher. So, I mean, they're changing the distance and the elevation.
Yeah,
And
and
trying
even
to get
and even with that, it didn't help them much. It only gave them some measurements where it gets ambiguous because they're close because
Simply place.
So that's the argument that Jesse's been making over and over and over again, and they shoot him down and shut him down and say, no, 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 whatever. But that's literally like just backwards the same argument that, and he doesn't say, he says it's ambiguous, but I thought somebody said that it was either like a half a degree or a degree or something of difference between like with the elevation change and the 50 kilometers or whatever. So, I mean, if you're doing like some super accurate math shit, like, I think that a half a degree or a degree would make somewhat of a difference, at least not be completely, you know, then if that's the case, then why did they move the observer to begin with? You know, like it's like the guy who's on their side here asking them doesn't realize that they're the ones that first moved the observer to begin with from Mike's house to the peak, right?
Right. And their whole method sorry. Their whole method is based on, you know, them pre-assuming a flat earth, because if you take a straight line measurement through a mountain peak to the star, if you assume a flat baseline all the way, you know, to underneath the star, then you're assuming a flat earth and you're basing it off of that. But if you're assuming a globe, then the angle measurement, you know, the baseline from the mountain to the star would be lower because the curve of the earth. And I don't know how they take that into account. Like if, you know, if the 69 miles per degree or whatever is correct, or at least correct for the globe prediction, then yeah, it'd be like less than a half a degree, just a little less than half a degree that they would have to compensate for, and over distance, that's, you know, that's gonna make a bigger difference.
Yeah, it's not negligible, like he says. But
Right. Which I'm not going to go through and do all the math. It just shows that they're pre-assuming the flat Earth to begin with, and it works. But if they take like the true globe, an actual globe prediction, you know, that angle from the mountain peak to the star would be different. And the whole deal with refraction, which their guy even showed, which I was going to say a minute ago, whenever you were showing that video, whenever he does the little demonstration showing the light doesn't occlude until the actual object goes in front of the light source.
yeah, and
That's
gooses.
true that it didn't block it then, but the timing was different. Like it changed the timing of when it got blocked because it slowed the light down. And so when they take the timing measurements of the occlusion timing measurements, they're saying that's when it happened and that's the angle they're taking. But if the starlight is being refracted, the timing is going to be different. And so when they take that timing in the stellarium and take that angle measurement from that time, that's not the correct timing. When the actual position gets, you know, if it is an exact straight line with no refraction, then that would be the measurement. But they don't know what the light's doing exactly, so they can't claim that the light is just perfectly going straight. Like nobody can claim that. When nobody can claim that they know exactly what the light's doing all the way from the target to the, you know, observation from the observer.
Yeah. No, that makes total sense. Like,
But their own demonstration showed the timing difference. It even says it, like I've got the clip of the whole guy doing the demonstration with the little refraction deal.
goose or whatever, right?
Yeah, Goose. I've got that whole deal, and he even says, yeah, that's the timing difference, which is correct. Like if the light's slowing down, maybe it doesn't get occluded till that exact point where it's being obstructed by the object, but the timing is different because the light got slowed down.
Yep.
Through the different refractive medium.
Exactly. No, you're 100%. Like that's and like as far as, when you just said like I'm not gonna do the math on this, like we're not even trying to sit here and like completely debunk like their math. It's the fact that they're contradicting themselves over and over, like by using their own methods and by like just thinking and like under comprehending the words that are coming out of their mouth, like you can't claim one thing 1 second about it not making a difference 50 kilometers and a half a degree or whatever it is, and then like it's like they don't even see that, or they don't even explain it either to their listeners. Like their listeners are like straight up like asking them the same thing that Jesse was asking them. Jesse gets freaking, or not Jesse, but Electric gets banned or muted for saying the same exact thing just in a different way, basically like flipped backwards. But it's like the same point that he's been making over and over again, and it's just, I don't know, it's pretty crazy the amount of like excuses that they're making instead of just owning up. Like I would have much more respect for them if they were like I know that we've done 15, no, more like 50 theodolite videos, because like yeah, they have like the part 1 through, oh yeah, and that's another thing too. I couldn't find part 1 through like 10 of the Celestial Theodolite. Like they're not on his channel. They're like deleted or something. And that's really weird to me, because when I went back and was trying to find the very first time that they were talking about it, like I think the Globebusters may have been one of the first, and it was called like the null hypothesis or whatever, and actually Witsit was in that. And then in all of the other ones, when they talk about it, they reference it like, oh, in the last one we talked about this and that, but then you can't find the last video. So, I mean, it reminds me of just Globebusters in general deleting all of their videos, all of their past stuff, because maybe there's something that they were trying to like cover up or hide from. Like, why wouldn't those all be there? I don't understand that. Like if you're really pushing this that hard and whatever, like you would think that you would leave all of your videos up, and the fact that there's so many missing ones makes me think that there's some sort of a cover up or something going on. But that's just my own side conspiracy that I realized when I was like trying to go through all of this and find old clips and everything. So we'll keep going
the observer
here.
wherever it takes to get the angle that you want, right? So you realize that, right?
So I'd have to say the fact that you asked that question means you too missed the point that it's not any observer who's occluding that star. It is Pike's Peak that is occluding that star. Therefore, you need to see where the star was relative to Pike's Peak. If you choose another peak like Ayers Rock, you see where that star was relative to Ayers Rock. The point is you need to set stellarium whatever it was that occluded the star, not to the location of who observed it.
I disagree, because I recently did a test with a real theodolite that measures to the nearest half an arc second, and I measured the angle to the sun and recorded the exact date and time, and I put stellarium for my actual observer location, and it matched. But is it also true that your observation of the occlusion of the star also matches what would happen on a globe?
Could you repeat that question?
Yeah, is it true that your observation of the star and the results from stellarium would also be what we would see if Earth was a globe of the claimed size?
Now, are you talking about the observation from the location of the observer?
Well, you moved
Let me ask you a counter question.
You notice Jesse was about to say you move the observer, and he cut him off real quick to like answer his question with a question. Super
Right.
dishonest.
Something occlude your observation of the sun?
Nope.
The answer is no.
But I don't see how that's
very,
relevant.
very
Dude,
relevant.
it's super relevant, dude.
You see, exactly. Still, they want to like, oh, the sun's brought up. Nope, like can't do that. Can't bring up the sun, even though it's like he wasn't really making the same point we were making, but still, like, I don't know, it just made me laugh that like the quickness of like the gatekeeping and the like cover it up, don't let him keep talking, like change the topic, like it happens so much in these conversations. It's like embarrassing.
Oh yeah.
Shouldn't.
Well, hold on. So why don't you count Stellarium's other angle from where that the house is, right? Like I mean, if you're gonna use Stellarium as a source, right? Shouldn't you Shouldn't all of the numbers be relevant? Or like, how can you...
No, because you're applying corrections over distance for curvature.
Right. That's the point. It doesn't match.
What's up, dude?
Oh, so this is what's his face, Q up and you. um, but yeah, did you want to say anything else about? I think we pretty much covered all of that, right? Or did you want to add
Yeah,
anything?
no, we covered all that. You can even skip through this. It's retarded.
I know I had to though because this was a big discussion that between like Jeremy and QOP for like a week, and then QOP comes in and tries to like lie and pretend that that didn't happen basically, and just the whole conversation is really funny. And Taylor at the end trying to come in like she's straight up like literally sleeping still. I'm like, oh, she's sleeping on the job, you know. But anyways, we'll just let it play really quick.
I said that was embarrassing last night.
Why you say that?
You and Rusted turned the Ether Cause presentation into like fucking daycare for children, teaching them perspective.
Who are they teaching perspective?
To you two and Earth is life. It's ridiculous.
How are they teaching me perspective?
So you guys are asking about what a parent, what it means, like an apparent star, what they were talking about. You guys didn't even know what they were talking about. I don't know why you guys were talking.
What was I wrong about?
You weren't wrong. You were just confused about shit that no one wanted to hear being explained.
Says who? Says you?
Even they were complaining.
Who's they? Wait, weren't you just complaining weren't you arguing about a star being underneath your feet and they weren't calling it an apparent position before?
What are you talking about?
Right there. Fucking lie. What are you talking about? And then this next clip is from him like a day or 2 days earlier than this, right before this conversation. So I know I like just cut it in and it just starts playing, so it sounds kind of confusing, but just know that's when that happens, that's just a flashback of a couple days earlier.
A star being below your feet, is that an apparent position or a true actual position of a star?
Apparent.
But they're saying it's a true actual position.
No, they were saying, so if they didn't say geometric position, they said what they call it, they have, I forget what the term they use. Do you remember what they say? What they call it?
I'm sorry, I just can't. It's so funny that he's like, "You're so stupid." Wait, what do they call it?
They were calling it actual position.
We know where the star's geometric position is. When you say that, do you mean in the globe model, like to compare with like the flat Earth predictions, or what do you mean by that?
So the true geometric position of the star comes from zenith measurements of said star at a certain time, right? Like when it's straight overhead, and then comparing that.
I'm still confused. Anyone not confused?
Yeah, you're confused about a lot of things.
I just feel like you're not explaining it easily. Like,
all right, do you trust the nautical almanac?
You're using globe measurements and a optical sky map together to prove that they kind of debunk the claims of the measurements of the Earth, but that's still globe measurements. Like they took those, so you're appealing to their measurements.
It's about proving the null hypothesis, though. That's what it really is about. his null
off the ground, but you know he's 30,000 feet.
This is why I told you guys. I don't know why you're using the term geometric position, because you're making this confusion.
It's geometric in the sense that you're drawing straight lines from the center of your azimuthal field of view.
It's optical though, Shalom.
Horizon, the flat part on the bottom.
Yeah, we get that stuff, bro. I'm
Yeah,
just
okay.
saying, like,
That's
you're
what we're
drawing lines
measuring.
to an apparent position. When you guys say geometric position, you're saying that it's actually there.
Yeah, but the thing is, Jeremy is uncomfortable with drawing straight lines to stars because then technically you can guess a height, right? An altitude of the star, but we don't care about
Yeah,
that
that's
because
not
the
why. That's
idealized
not why,
altitude is
Beast.
6210.
That's
That's
not
it.
why. That's not why I'm uncomfortable with it. I'm uncomfortable with it because now we're above a star. That's what I'm uncomfortable with.
Like we're above the jet planes. Angular elevation may
Oh,
be
why
a
you
couple
guys
degrees.
explaining perspective to him, dude? He's a flat earther, dude. You guys are not like
It
understanding
is
what
weird.
you're saying is wrong, and he's right, and he's just. You guys just need to
Yeah,
stop saying geometric position. I told you that. That's
Can
the whole problem.
like, dude, if everything's in its true position,
Wait, weren't you just complaining or weren't you arguing about a star being underneath your feet and they weren't calling it an apparent position before?
What are you talking about?
A star being below your feet, is that an apparent position or a true actual position of a star?
Apparent.
But they're saying it's a true actual position.
No, they were saying, so if they didn't say geometric position, they said what they call it, they have, I forget what the term they use. Do you remember what they said? What they call it?
They were calling it actual position.
Yeah, something like. Well, they just mean like without refraction.
Without refraction.
You know, in the stellarium, like celestial sphere.
And that's just perspective that makes it go below your horizontal?
Depends how high you are. It doesn't ever go below the horizon.
I thought. Okay. But a star that's above your head it's fine for it to go below your horizontal? That means it's below your eyesight?
Optically, you can go if you're above the horizon.
Yeah, they
Well,
kind
why
of
does it?
disappear before they hit the horizon.
They disappear before they hit the horizon. Is that right?
Mm.
Yeah. So how are we making an observation of tiny little fraction of a degree below horizontal and it hasn't even hit the horizon yet?
Well, it's obviously not. Whenever they're making that observation, the star's not all the way near the horizon yet.
But it's still below your horizontal, so the star is below your eyesight, your horizontal?
Who said it was below horizontal?
Like, tell me she doesn't sound like she literally, like, her handler called her and was like, you better get up and start doing your job and gatekeep this shit. Like, it's just so ridiculous.
Well, it's a negative angle from your horizontal.
I don't know if that's the case. I don't think so.
Oh. I thought that's what Dr. Mike said, and that's what I was trying to get clarification on.
No, because that would mean the mountain would have to be lower than them, and that wasn't the case.
Oh, I thought one of the peaks he said was lower than he was on Pikes Peak, and he was looking at another mountain that was a little bit below, which he didn't realize was a little bit below, and he saw an occlusion, and it came out to a negative angle.
Okay, well, if he was higher than the target, then that might be a negative angle, but that doesn't mean that the star's touching the horizon yet, or near it.
Okay.
She clearly has no idea of what any of this is. And you can see there's other clips here in a minute where everyone's like, dude, like, you're here. How do you not hear what's happening? Like, and she's like complete ditzy, like, I don't understand how how she can be this out of it, but still try to have an opinion on it. It makes no sense.
But it does. It may not be to the horizon, but that doesn't mean it does mean it's lower than your horizontal sight, your line of sight.
Right.
So, and that's, I guess, just perspective that makes it go below your horizontal line of sight, because the
I mean,
star's not actually
if you're on an
down there, right?
airplane, if you're on an airplane, it can get below you.
And that's what they always bring up is the freaking airplane over and over. Geo and her and everybody, like it's like they all got the same memo that was like, just keep talking about airplanes, guys.
Your horizontal.
Yeah. I just kept
Right. No, I
I just
agree.
kept
It does
wanting
go.
to,
Sorry.
whenever the night before when I was talking to Alan in there, I just kept all I wanted them to do was to admit that things can only go below your horizontal because of light bending, refraction, whatever they want to call it. But I was just trying to get them to admit that, and it was like pulling teeth to even get them to say that light, in order for light something above your head to go below your head, then something's bending, and I couldn't get them to admit it, and that's all I'm doing here is trying to get people to admit that light has to be bending in order for something above your head to appear below your eyesight.
Right. And they just want to
So
keep claiming straight lines to everything, like as
yeah,
if
well they
refraction.
say perspective. Yeah, they say perspective. This is how you see. This is how they see, but they won't say that that's bending light. They'll just say that's just how you see. But there's perspective. We have a definition for perspective, and it's straight lines, which I understand when we fight with the Globers about this is how we see, that's perspective, whatever. But I mean, there is a definition for perspective, and perspective is based on geometry, straight lines. So I agree with the Globers when we say that it's just perspective, that's not correct. Like light has to be bending in order for something to go below your horizontal.
Exactly.
And so that's just what I'm trying to get all these flat earthers to admit, mainly for my other ideas, but that's what I was doing here with her, just trying to get some confirmation from these people.
Yeah, exactly. Which is clearly she's like just waking up, hasn't been paying attention, and you'll hear in her other clips how little she actually knows about this whole topic.
Go below your horizontal, but I don't think that's in its actual geometric position.
Okay.
That would be caused by something.
Well, you're gonna
maybe if it's just perspective, then it's just perspective. But I always assumed perspective
you're
to
gonna
be
input
actual.
your elevation. To get a star's position, it's gonna depend on where you're at. There's things you'd input, including your elevation.
$60 every time. It's wonderful.
I'm so
Yeah,
glad you
and
made
see,
that chart. That's super cool. And y'all should do a presentation on the celestial refraction.
oh, there's been a lot of them.
I think I did one. Did I not do one? Or yeah.
A dozen?
Yeah, several. Every time we do, yeah, I do it
We do one
often.
every week or whatever.
I do.
Yeah.
Piezo just did one live. He just Taylor. He just did it. All the keynotes were there.
Should be noted that this has no correction value.
You
and
noted
no
nobody
adjustment.
invited me again.
You're here.
You're here right now.
Taylor, you're here.
Oh, you know what Taylor said the other day? That she needs custom invitations to everything we do, or it doesn't count. So
Yeah, I know.
Yeah, add up plane trig, drop over distance, terrestrial refraction, celestial refraction. Guess what? That simulator he built using all that correctly will predict the measurements Mike made on his spreadsheet in the real world.
Yeah, I guess I know you explained it 3 times. I guess it just wasn't hitting home because he told me like he didn't use any refraction. So whatever. Okay, thanks.
That's the way that it works. It wouldn't work at all if you didn't incorporate those two refraction corrections. And
Jason, that was embarrassing last night.
Oh,
Your
why
own
is this
spreadsheet.
playing?
That's what I ended up doing.
Sorry.
And it made it way easier to understand and interpret it. And I had like several epiphanies going through it that I should have had a hell of a long time ago to better understand this and move it forward. So
spreadsheets, right?
That's right.
And then if you do that with both spreadsheets, you'll notice that the methods are entirely different.
Yeah, dude, that was a big one for me today when you showed me when we went through that. Do you want to pull up your slide and go over it real quick so we can kind of have like a nice breakdown of what you've been laying out too?
I think you nailed it, dude. You've been absorbing it. You asked me to do it, and then you immediately summarized it concisely and perfectly. So I think it was fine.
So this is the part I was talking about where this was from like a week ago or maybe a week and a half ago, where he's like, I wasn't even fully understanding it until you showed me like your spreadsheets. And then when he's like, here, go ahead and show your spreadsheets, Shane's like, no, you got it. And like, what about the rest of us? Like, if it took the guy who's presenting this months to understand, and only through these spreadsheets and through Shane explaining it did he finally understand it, now all of a sudden, like the rest of us don't get to see those or whatever. I don't know. It's just a weird, very weird conversation. And to hear, for months before this, like Alan straight up like going in on Jesse and how stupid he is and how, whatever, and then admitting here that he didn't even understand Jesse's method until just now is like very telling about how dishonest they actually are. Like that's like if you don't understand it, then just admit that you don't understand it. Like don't pretend like it's like fake it till you make it sort of shit. Like other people are telling him that it's bullshit, so he's just repeating it, just like all of their minions. But they trust him, they trust these guys, so then they just turn around and repeat over and over because, well, they wouldn't lie, right? Just like the government, everyone else, and NASA, right? They wouldn't lie.
It's always good to see, right? No need to hop in if you're nailing it.
Yeah, it just like I totally forgot about the true position. I kept thinking in terms of the refracted position because they want to go here and talk about this. And I forgot when we were talking about how the 2 pi versus the 1 pi, like having it comes out to be exactly half for what the mountain was. I was like, but it was just kind of lost on me. And earlier, right when you left, and I had just got this working, I had an epiphany. I was like, oh my God.
But that still works fine.
Yeah, now that I see the difference, like mechanically, that's not gonna fly anymore. That's over with, dude.
Now that I see the difference mechanically. So for all these months, you didn't understand the difference mechanically, but you claimed to understand the difference mechanically this whole time. That's like where my issue, I guess, mostly comes in, is like faking it and acting like you understand something that you just admitted that you don't really understand. And then all of your minions are like, it's so simple. It's so simple that even the guy presenting it didn't understand it until just a week ago.
That's why Mike.
Dr. Heffron, I just wanted to say that your
See, this was an example of one of their minions that every single episode she comes in and says literally the same thing, pretty much, like word for word almost. And her mic is turned down super low, and you can hear, like, that was me turning up the volume on it. Not even, or no, he turned the volume up at first, and then I had to re record it and turn it up even louder because she was so low that you couldn't hear her on the live stream at all. So, like, they're like, oh, yeah, anybody can ask questions. You're just going to ask a question, and it's going to be so low, no one's going to be able to hear you unless you go back and find it in the live stream from EA.
method and your experiment is so brilliant in its simplicity. And I say that because when it's so direct and simple, it's almost impossible to screw it up. So it's sort of foolproof. And I think that that's because of the brilliance of the simplicity of it. So thank you so much. This is what did that guy say? This is a body bag or something? It's just it's phenomenal.
Body bag.
All right.
I have a quick comment if that's okay.
Absolutely, Lily. What's up?
Yeah, last time I was saying that Dr. Heffron's method and his praise important to have people steel man our position. Otherwise, they end up wasting so much time asking such basic questions like, why does the sun go out of view if there's
She's talking about me right there. That was right after I made my sun comments to them, which clearly went over her head.
no actual mountain peak, preventing us from seeing it, stuff like that, that it just turns into a waste of time because we're just repeating really, really basic concepts. So praise the originalness of this thinking enough. I know that you give the credit to God, which is fine. I don't mind doing that also, but you were the channel. And so, but I hope that it inspires our community to come up with such original ideas and thoughts that are brilliant in their simplicity and their originality. So I just wanted to point that out. Thank you. And also, I think, after what is it, 3, 4, 5 months of discussing this particular subject, this particular issue, I feel like if people aren't getting it, then it's either like, I don't know, it's a dishonest, intellectually dishonest, or it's just mental incapacity mentally to really get something that maybe
Like it was just kind of lost on me. And earlier, right when you left, and I had just got this working, I had an epiphany. I was like, oh my,
Bids are entirely different.
yeah, dude, that was a big one for me today when you showed me when we went through that. Do you want?
Right. Do we want to waste everyone's time and reverse engineer my 219 back into a distance? Is that what we want to do?
I did the same thing.
Do that, but it'll take
I did the same thing, doing the same
clearly
process.
You didn't, because you're off by 4,000. Clearly you didn't.
Okay, well, let's see what we did here. We did E12 plus B19. E12 is standard refraction. That's globe slant.
No
okay,
one's,
one second.
No one's going to watch this, Alan.
I don't care.
Tangent of the radians. That's it right there. Divided by the tangent.
Or which one? What was this one?
Basic angle, globe angle, divided by the tangent. Yeah.
That one?
Wait, no.
So, and this is another thing I noticed, that they go back and forth between like Alan sounding like he doesn't know, and and Shane is like walking him through shit, and vice versa. Like it goes both ways. It's weird. It's like all of this was neither of theirs, and they're just like fumbling around trying to figure shit out, and their handlers are in the background like, no, this one. It's pretty much the vibe that I get off these guys half the time when they try to explain stuff.
Whichever one.
I mean, this is what
What
we're all.
exactly is your argument?
And then
Exactly.
while like so they're struggling to just figure out some basic shit, and Beasticles comes in and is like, distract. So what's your actual point? Like this is what they do every time. It's like this strategy that they do where like, they're getting put on the spot with something and they can't answer something, so then one of the other guys jumps in to distract and be like, oh, change topic, whatever. It's really obvious what they're doing.
Is your argument?
Me is
You
that
laid
it's
out?
the globe, which I'll show in 1 second.
Yeah.
Yeah,
Distance times the occlusion angle, bro. Or whatever the refracted angle is. And in your case, you wanted
Yeah,
in your case, you wanted 219, so it goes off of the 219 angle.
Yeah.
Yeah.
Right,
yeah.
but where do you account for drop in refraction, which are input into the formula?
In 219 already.
We already did.
We
already did. To get to 219, we had to subtract the drop over distance, which was 213 from the flat Earth prediction.
I mean, I was just here last week, and Ruhef said
Hold on,
219.
Toby. You got your voice changer on again.
Yeah.
For some reason.
Is that Toby?
but yeah,
I never turned it off.
There you go, Toby. You're live.
I was gonna say I was here last week, and 219 came from Ruhev.
Yeah, I'm 219.
So how many, I wonder, Toby has been gone for like months. He probably didn't go anywhere. He's just got his voice changer on and he's going around LARPing as different people in different things. Like that shit was hilarious. Sorry, are you still with me, or did you get a client? Are you at work right now and you're like doing stuff? Or are you still with me? Or maybe you're muted. If you are, I can't hear you. It's okay. I know that sometimes, I know he's at work, so he might have people coming in and trying to talk to him, so I'm just gonna keep playing this, and if he wants to jump in at some point, we're here.
It's pretty much still goes the way of flat Earth. In a couple of cases, it's ambiguous. When we go raw for raw, you guys are off. All we're doing trig based off of. We don't care about the actual elevation of the mountain. So
you're aware that Stellarium thinks you're at sea level.
So once again, we don't care about the actual elevation of the mountain, but like, wasn't that one of the points? Like, what isn't that one of the measurements? Like. So fucking confusing how they flip-flop back and forth between it being important and not being important, and I don't know.
All right.
Are you aware that? Oh, so you're saying that there's a different refraction or a correction that'll be applied there?
That's all I think there. I have a quick comment, if that's okay.
So this is maybe why the celestial theodolite is so important, because you can get right into the weeds with this, even though I just told you it can be a kinematic equivalence, because it's how you're just interpreting the data, because there's no physical measurement of the ground. And so, yes, this is why the celestial theodolite is very important in understanding why the flat Earth prediction makes the more accurate prediction.
Well,
A far more accurate prediction.
prediction of what? How do you predict an azimuth using flat Earth?
Oh, so were you just not here for the Celestial Theodolite?
Not the the whole time. I'm talking about how the azimuth gets predicted. Actually,
Well,
if you look at the, yeah, go ahead, sir.
Well, you're gonna have to see the whole observation for itself and exactly what's been going on, because you sound like you're probably smart enough to be able to get it if you spend some time with it. So I guess
Sounds to me like he doesn't understand and can't, so he's trying to like obfuscate and be like, "Oh, were you not here? I guess I'll just re-explain it to you," and then continues to not explain shit.
I'd encourage you to do that. You haven't seen it already and you're not familiar with what we're talking about. If I start telling you about it, it's not gonna. I don't think
I'm
it's
familiar.
gonna.
And I saw a spreadsheet. Someone shared a spreadsheet. And the spreadsheet uses the globe formulas for azimuth and elevation.
Oh man, I mean they already beat the horse to death. I mean I can explain it again, I guess, but they go through it more thoroughly than I do. If anybody wants to go back on it.
Yeah, no.
I'm sorry, would you run that by me again?
When you form a triangle, you are making concrete the elevation of the star above flat Earth. What is that elevation?
Well, because you're using its apparent angle and that occlusion timing, that's all that really matters.
Yeah, but
so like when you talk about turning refraction off, you're moving. That's not where you're seeing the star. Where you're seeing the star in reality is what happens when you turn refraction off in stellarium.
But you've said, I just want to repeat this because you didn't answer. You've said that it forms a triangle. You are at one point of the triangle, right? There, and what are the two other points of that triangle?
So I think you're moving the observer again. All we're getting is an angle, and that's what's important. And the angle is provided by the occlusion timing.
But you said that forms a triangle. I want to know what are the points of the triangle.
You can use either, because like I said, you're starting with an angle, not necessarily a point.
No, let me remind you. You said it forms a triangle. I want to know what the 3 points are of the triangle.
Well, the first one is the angle to the star, and then you can either use the known elevation of the peak of the mountain you're using, or you can use the distance between the mountain and your position.
I don't think you know what points of a triangle mean. I keep asking, what are the 3 points of the triangle? And you still are unable to answer, what are the 3 points of the triangle?
Oh, that last point is what you're really getting at, and that's where the accurate distance happens for a flat Earth prediction. Sometimes the globe is off by 10,000 meters.
When I ask for a point, and your answer includes the word distance, you're not answering what are the 3 points of the triangle. So I'll ask again, what are the 3 points?
Worded question for this, and it's part of the point of the Celestial Theodolite, is you don't start with an angle.
What are the 3 points of the triangle that you're talking about?
The peak of the mountain.
Okay.
The base of the mountain.
Okay.
And then the prediction that is made by either a flat baseline or a curved one that you assume. So that's the third point.
The peak of the mountain, the base of the mountain, and the observer?
The peak of the mountain, the base of the mountain, and the calculated position that can be either your calculated position or mine. And one of them is more accurate than the other.
Position.
Most of the time, the vast majority of the time.
The location of the person doing the observing is the third point of this triangle?
The third point of the triangle is either by your calculation a globe Earth position, or by my calculation a flat Earth position. And in my calculation,
Jesus, guys, like it's so hard to listen to this whole thing. I'm sorry. I should just fast forward through some of it here because it's embarrassing for him, for everybody.
The third leg of the triangle there. When you get two angles, then you know the third one.
The baseline. When you say the baseline is between 2 points, what are the 2 points that are the baseline that have the baseline on either end of it? Right? What are the 2 points? Why is this so difficult? There's a triangle you've talked about. I just want to know what the 3 points are and the names of the different sides of it. And you said baseline. I don't know which of the line. Name the line which is between the 2 points that you've. There are 3 points on a triangle.
They just
Super easy.
Keep going.
Point 2. What's point 2? Where's point 2?
See, it's not, man. You're trying. So the observer point is the point in contention.
Yeah,
here.
we've already identified point 1 is the observer. Where's point 2? could have just said them, and we'd be done with this part
Okay,
of
hold
it.
on. I got you. Point one
The
is the
observer,
mountain
the
peak.
peak, and the star.
Oh, thank you. Peak? Who said that?
The peak, not the peak, the base of the mountain, and very specifically, depending on how you interpret the flat line between the bottom on the ground, dog.
Between the observer and the base of the mountain?
I would say that, yes.
Okay. That was hard. Base of mountain.
But do you get that we're deducing the accurate?
No, we're not there yet. Hold on. Base of mountain to observer. All right,
Yeah.
now
And
where
one gives you an accurate answer.
So now I'm asking the next one, the next thing. We've got the baseline, we've got the 3 points. Where does the star come into play?
The star gives you an angle, and that angle
is this another
will
triangle?
give you an accurate.
Are we making
give you an accurate distance to where you believe your observer to be?
Are we making another triangle since we've got another point, or does this coincide with one of the other points?
It's a 4-pointed triangle. Somebody put that in the chat, maybe that. It's just
I guess I
silence.
don't really understand your question. I'm trying to. Or what?
Well,
I mean, you got 3 angles. You got, your angle to the star there.
That we talked about earlier.
So this is important. So you don't need to punch in your location in Stellarium to get your accurate location when you use this angle, and that's the point.
That's not true. You need an actual.
I don't. I'm not getting what you're saying here. So
that you can derive your distance. Go ahead.
2 out of 3. Yes, you can derive your distance, as Gio was about to say, when you get 2 out of 3 sides of the triangle. And when you try to add the third side, assuming a globe, the distance is off, sometimes as much as 10. Interestingly enough, when you turn off refraction, you get what you actually see. How accurate it is.
But how did you know? How did Stellarium do that? Did you have Stellarium figure the angle without knowing the position? Stellarium doesn't do that. You put in the position. That's how Stellarium works. Step 1, choose a location.
Yeah, and he did say that a second ago that he like. So, I mean, I don't know. I just think this guy, Angela Alchemy or whatever, is I mean, he what was it, like a week ago or 2 weeks before this was recorded? He came in fresh new in the conversation. Oh, I'm just catching up, blah blah blah. Like he should probably be the last person to be in here talking about um any of this. And then we had a conversation after the other day when I was asking questions, and Gio didn't want to answer some of my questions, and so then Gally comes in and is like they both are like, well, it's not my claim. Like they want to avoid answering a simple yes or no questions. Like they don't even, it's like they just want to, say that it's not theirs, so they don't want to answer. And I don't know, it just doesn't sound like people, like if it's such a simple thing, like everybody keeps saying it's so simple, then how come it's so complicated to try to explain 3 simple points? Like that's, I don't know. Anyways.
Then it tells you the angle to the star. That's how Stellarium works, right?
Yeah, I believe so.
Okay.
I think that might have been done outside of Stellarium, but the numbers are all still there. Anybody can go check on it anyway.
Yeah, and so Jesse did, in fact, and he got numbers that matched the globe perfectly using the same methodology. Amazing stuff.
Which was that? That wasn't Blinn Mountain, was it?
Yes, it was.
Oh, cool. Funny. There's a video about that. I won't get into it.
All right. Well, you had your 15 minutes. Thanks a lot. Data, Flat Earth Data goes by Jack.
Okay, I guess that's where it was misleading for me, because I feel like in the beginning he was like, I got this David Weiss whatever thing, and it matched perfectly with Flat Earth from my house. So then why would he go get a second theodolite, make a second observation from his house, but then not use that in the equations? Is what I'm confused at.
All right, well, I'll give here's my understanding of it, and if anyone else wants to correct it if I'm not fully right, but here's my understanding, is that the actual method itself just uses the timing. However, in order just to have all the things covered, my understanding is that Mike Heffron did use 2 different kinds of theodolites. One of them was and this is what he has said on this live stream, so I'm kind of just trying to steelman it, that even though it's not necessarily part of the Celestial Theodolite method, as far as I understand it, it's not part of the actual method, but because he was doing all this, he wanted to check it. And so he got a newer style theodolite, and then also he had an older one, a more traditional one. And from what he had said, which I know he's clarified it, so I hope I don't get this wrong, but he had said that the new one actually got technically the like 217 or whatever optically. So this is not the timing.
So where
From the
does
ground.
topography come into it? The calculation.
Well, hold on. I'm trying to still figure out what Rusted was saying. So are you saying that?
Yeah, no,
did
that's
they
a good
measure-
question. What he just said, that's a, yeah. Is there? So everything that the measurements they're going off of is off of Stellarium. There's not like he's
Yes.
not out there making anything.
Which is the globe.
physical.
Which is the globe system.
There's
Stellarium is the
not
globe system.
measurements. It's timing.
Yes.
No, it's nothing
not
to
a
do with
measurement.
timing.
It's
It's
timing.
nothing to do with timing. That is
Bullshit.
just what you believe.
Right, Gary. No.
Wait, are we confused on do people know the distance from one place to another on the earth? Like do you guys understand it's derived off the nautical mile, that's 1 degree, there's 60
Do
of
you
them.
understand photography?
Here he goes.
Well, here, can someone answer like Galatrax? Do you like to what? If you had to summarize, to what degree is Stellarium used or not used? If you want to.
What's topography?
Just hold on.
I think Stellarium, if at all, would be used to get the
Ephron's
globe prediction when you're trying to compare them. But it's not my claim. I'm here to moderate when the presentation's going on. But are you asking, like, is Stellarium used for both the globe prediction and flat Earth prediction? I could ask.
Well, it's used at the top.
Like, if this is so simple, how is this such a hard question for anybody to answer?
Right, to get the
globe
elevation angle
predictions.
from the top.
I guess when I first heard it all, I thought that they were using a real life like measurement that he took with a theodolite from his house. And so then when all of a sudden the observer moved from his house to the peak of the mountain, I was like, oh, cool. He like went on a hike up to the top of this mountain or what? Like, how do you just move an observer? Like that would be the observed object. That wouldn't be the observer. Like just basic English just got me confused on this.
Can I
shit.
help you? Yeah, can I help you understand that? Can I help
Yeah,
explain that? Okay.
go for it.
So the reason why he called it a celestial theodolite is because what he's doing is he's sitting from his house and he's watching the star get occluded from the physical mountain. He's using the mountain as if that's the crosshairs on a real theodolite. It's a conceptual model, right?
Got it.
So he's not putting himself in the position of the mountain peak like that's where he originally observed the star from. He's using that as if he has a gigantic, like, conceptual theodolite and the crosshair is the mountain.
So it's like a make-believe person up at the top of the mountain, basically. You got to
It's not even a
conceptualize it.
make-believe. It's
Well, if you're
it's just
conceptualizing, that's like make-believe,
yes.
right? I mean,
So just
So the instrumentation that gets the timing extends to the tip of the mountain. That's how it
over
works.
distance, there's going to be a change in the measured angle. You got 1 degree per 60 nautical
Incorrect,
miles.
Jesse.
Well,
Hold
that's
on,
why that thing I
Galatrax,
mentioned,
want you
it's
to
not
understand
about
this.
this is
Please
not
let
about
me-
the optic.
Please let me clarify.
I do.
Thank you. So from the observer to the peak, it's 50 kilometers, right? Over that distance, the degree should change by half a degree. That's not what you're claiming is happening with the celestial theodolite. You act like that the elevation angle to the star is the same from his house as it is from the peak. That's not what happens in reality. So it all falls apart. You're just already done.
What does that have to do with the star that's behind the mountain getting occluded by the mountain?
Yeah, you could just measure the elevation angle to the mountain, which was already done, and it matches 2 degrees, 19 minutes. Not your flat Earth prediction where you pretend there's no atmosphere. The flat Earth
It's not my
prediction
prediction, and that doesn't answer my question.
It's not my prediction. Doesn't answer my question, but they don't want to answer real basic yes or no questions either. So, anyways, yeah, I don't know. I mean, take all this information in and make up your own minds on it. I just think it's kind of weak sauce. But I gotta go do a bunch of stuff today, so toodaloos. And
Hello.
oh, what's
Hello.
up?
Can you hear me?
Hi. Yeah, I
Can you hear me? All right.
Yeah.
Okay. Sorry. I was
No,
back. I had a customer I deal with.
No worries.
But yeah, I was listening to Jesse or Electric is right on that and it's dude Beast or not Beast Galatrax or whatever talking all slow and loud. He's so retarded.
He's so annoying.
The point went right over his head that like
Yeah.
you can take that straight line measurement through the peak to the star, but that doesn't mean if you move the observer up to the mountain that the baseline is going to be the same for that triangle. If you're on a globe, the baseline would be tilting down. So that's why that's their argument, and they're taking that measurement that was assuming a flat baseline all the way across to wherever the star would be at 90 degrees, and assuming that the star is at that degree for a flat Earth measurement. Which okay, that's what the flat Earth would predict, but you don't know that baseline up. Even Solarium says that baseline up at the mountain is different than what it would be from Mike's house.
Yeah.
And so if you assume flat Earth, then you're gonna get the prediction, that matches to that.
Yeah.
Which, I potentially agree with because I'm a flat earther and I don't believe it's a ball. So, but it's not conclusive if you don't start the measurement off in the beginning, right. So
it looks deceptive is what it is. It looks
right.
like, and for them to not understand where we're coming from, it's just to me it seems like, okay, well then you guys are doing this on purpose. If this many people have pointed this out this many times and you guys are still doubling down on your answers, like it's and I mean, if I haven't done like the math as far as what John was talking about but I think that's what Electric keeps bringing up, is that the flat earth trig or whatever doesn't match up with
the measurement that actually would be taken.
Yeah, if that, I mean, that should be something really that, I mean, I don't have like all
Right.
the
And
time in the world.
that's why it's right. That's why it's ambiguous. And I say that all these people are just Jaren number twos. Like they're going to the sky to try to prove what the ground is. And it's all optical up there. Like they think that, okay, they're using stellarium. Well, that's the end all be all. Or even if they're not taking stellarium, they're taking any other star chart deal that shows that, okay, they're starting at the point of Aries and taking 15 degrees per hour from that. Like, okay, so you're assuming that the stars actually do this 15 degrees per hour, and don't move out of this exact path, and that this exact path isn't refracted anywhere, and you like it's equivalent to like laser tests or even long distance observations where you don't know what the light is doing. You can't depend on, you can make predictions off assumptions, but you don't know. And that's the problem with it.
Exactly. No, I agree 100%. And yeah, I gotta head out to an appointment here in a minute, but thank you so much for coming on and helping me with this and explaining it. You explain things way better than I do. Like I can see the lies and the bullshit, but when it comes down to like technical explanations of things, like you definitely like help explain it a lot better than I possibly could. So I appreciate you.
Well, thanks, because I feel like I'm retarded whenever I try to explain things.
No, you're great. You're great. This is awesome. But yeah, you all have a good day out there and toodles.